Hello everyone. So finally I'm ready to show off what I've been working on. I'm really excited about this because we have been working for so long with Cerebral and watching the community change back and forth in terms of immutability, flux, observables, and all this stuff. And I think we have found a really good way to make Cerebral even more powerful. So it's a bit technical, but I think it will make sense. So let's just dive into this. So every Cerebral app actually starts with the container. So you have like a root element, and that is the container. And this container takes the Cerebral controller, and then it creates a context for all the components of your application. So for example, you would have a Cerebral component where you use the Cerebral decorator, you define what state it is interested in, and that becomes available on the props object of that component. But also the signals are exposed. You can do it in a stateless, like you use a stateless component instead. So then you don't use a decorator, you just call Cerebral and define the state dependencies the same way, and then you use just a function to define the component. But I'm going to use the stateful version because that's the one which is the most common one. Yes. So what happens now in the container, which is new, is that every component of your application will register itself to the container. So when it mounts, it registers itself to the container and it delivers its state dependencies. So if we had just one component here, which we see down here, it would register the app.title path to the container. And the container will now knows that whenever there's a change on app.title, it wants to render the app component. Okay. So when you fire off a signal, maybe you do some asynchronous stuff, and if there's a success, we want to change the title, and if there's an error, we also want to change the title. Nothing new here, and nothing new about how you actually update this title in the state tree. You just use the normal APIs for changing the state tree. But what happens when a change occurs now is different. Because now we're using something called a state tree. And what the state tree basically does is track all the changes in the tree. So Cerebral is able to, whenever it wants to, like when a signal is done running one or multiple actions synchronously, it will flush the state tree and it gets an object back which tells Cerebral what paths has been affected since the last time you flushed the state tree. Now, the thing is that if we now compare these two objects we have, inside the container, we have all the state paths related to components, and from the state tree, we get all the state paths that has been affected. So we can use the state paths that has been affected and traverse it, and then we can figure out what components do we actually have to render. So, for example, imagine this small simple app here. We have the container and we have the app and we have some items. So when this application mounts, it will register an object in the container like the one above, where the app is interested in the title, but it's also interested in the items. Maybe it wants to count the number of items. But the items component itself is of course interested in the items, and each item is interested in its specific item. the way we do this, like we've been talking about how to do lists, like should there be like a stateful lists component that grabs the items and then passes the item to each item component, which is stateless. And like the performance discussion around that, because if you do that, you still have to, you can't use a stateless component because you still have to verify that the specific item component should update, because you don't want to render every item component when something changes in the items. But with this approach, we can actually forget about that discussion, because what you do is that you pass the ID of the item or the index, whatever makes sense for your data structure, and you just wrap that item in a Cerebral component, and you use a dynamic state definition. So you use a function instead of an object, and you just tell it that this component is interested in this specific item. So now we have basically optimized this. So whenever there's a change specifically on items with the index 0, the only components that will update is the items, because there has been there has been a change within items, so items has to update, but only the component interested in items.0 or the index 0 will also update. So none of the others will do that, and this is just out of the box, and it keeps things more consistent. You don't have to think about this. With this approach, you always want to use a Cerebral decorator. Yes. So what does this give us? One thing is this optimization stuff, but it also gives the possibility to do some nice debugging, because now we have in the container, we know about all the state paths that the component, the application currently is interested in, and we know about all the components related to that. So for example, when there is a state change in the application, the container is the one actually telling each component to update. And by doing that, it can also make sure that there's some highlighting going on. So you can see like a border or an overlay or whatever that will actually indicate visually that there has been a render on the specific component. But we can also bring this into the debugger. So imagine inside the debugger, you would have like a list, like you see in the object above here, app title, app.items, app.items 0, and so on. And when you click these paths, Cerebral will do the same thing, highlight those components. So you can very easily see what components are interested in specific state paths that actually are active in your application at the moment you click. And that, I think, is really, really, really powerful. So I'm looking forward to implementing that. I mentioned immutability. So immutability has some benefits, like you can do time travel debugging very easily. You avoid mutating your state in parts of your application where you don't want to do that. But it also has some costs. One thing is that you can only use completely normal plain objects. You can't use any of the functionality of JavaScript that can be very beneficial. And there's also like an optimization thing. It's slower to have immutability. Yeah, I don't think there's anything else related to that. Well, yeah, of course. And then it's also referencing things. So you can't have one object in your state tree referencing another object in your state tree, because whenever something changes, you produce a new object. So that's like, you can't do that. So let's look at what we can do now using this state tree. So this is a post. It's just like a constructor. And what it returns is just a normal object, but it uses some nice JavaScript features. So the first item here, the title, is just, okay, we're grabbing the title from the attributes passed in. But the user is based on a user ID we pass on the attributes. So what we can do is say that, okay, whenever we want to access this user property, it should run this function. And that function just finds the user and returns it. And the same here for comments. We return comments based on comment IDs passed in on the attributes. And again, we want all the participants based on the comments, and we can return them as well. Now the point here is that these are not methods. We are not calling methods. We are accessing properties. So when we call this post constructor, and by the way, I have to say thanks to Brian for bringing this up. I would never have come up with this myself. But yeah, he was asking, can I do something like this with a new state tree? And yeah, you definitely can. But the point here is that when you call this constructor, you get a normal object back. So as we can see here, when we console log it, oh, I have a typo here. It should be user. Let me just fix this. I don't have to re-record everything. So we actually have a user here. And did we? Yeah, we passed in some ID and there is something there. Okay. Sorry about that. I thought everything was in order. Okay. So when you log out that post, you actually get the user, you get the comments, and you get the participants. And the point here is that this is not new objects. These are just references to what is already in your state tree. So there's a lower memory footprint that way. Okay, so let's move on here. So what you basically can do then inside one of your actions is to push a new post. And you give the title, you give it the user ID, you give it the comment IDs. Maybe that's from the input and not from the state. And then you just pass in the state so that these getters, as we call them, are able to find other kinds of state. And that will push an object into the state tree. And whenever these values are accessed, it will run these getters. So what's really interesting here is this referencing stuff. So for example, if we produce a new post, we could extract a user from the state tree, and we could just attach that as a user on the post. Or we could use the constructor to extract that user. The thing is that this is the same object. It's the same reference. So that means that when I go in and I change this user, this Bob user, when I have an action that changes the name of that user and I change it on the user's index 0 path, the state tree will actually understand that this object is also referenced on the post. So it doesn't only give feedback to Cerebral that this specific user's path changed, but also the post's path. And this is what the state tree does. This is what it's all about. It allows you to have references inside your state tree, and whenever one of those references change, it will also flush out a state change on whatever path the references were on. And that is all it does. Like the code is, I think, 150 lines of code. And what it does is expose an API to change things in your state tree, because it needs to control all these changes. And then it handles these references. That's all. Yes. So we can also do some more cool stuff with this. We can use computed. So with the constructor approach I was talking about, whenever you want to access one of the properties, for example, the participants, it will actually run that function. And you might think that that's expensive, but it really isn't, because the only way that property can be accessed is if one component in your in your app is currently mounted and is interested in the participants, and there's actually a change to whatever that component is interested in. So it doesn't change whenever something inside your state tree changes. It only changes when there's something in your UI which is interested in that update. Okay, but that is like the getters on a constructor factory kind of thing. And then we have computed, because the constructor stuff is more related to entities. And what we're talking about here is more typically like you have a list of items and you want to search them or filter them or something. So you want to combine two different states and produce a new output. So for example, I have this silly example where we point to a function and we point to a factory. So we can have a specific computed function, but we can also make a dynamic computed function. So let's look at the first one, filtered items. The way you define it is to call a function called computed. And it works much like a component. You define it like you do with a component, and that is with an object. And you tell it what state it is interested in, and then you give it a function that returns the result. And its state dependencies can also be other computed functions. So you can kind of like nest this all the way. So there's no like magic to this. It's interested in the current filter value and the items, and based on those two states, and if any of them changed, it runs that function which filters out the items. Yeah, and I have a typo here again. It should be value up here. It doesn't matter. You understand what I mean. And then we have the factory. So that's a function that returns a computed function. And we pass in the index, and we use that index to pick out an item in this case. And we also have some property called current highlight. I don't know what that means, but it's just for an example. And what we return here is a new object where we merge the item with the new property. And this is kind of interesting because we don't have immutability. So if I would say state.item.isHighlighted instead, that would actually be a problem, because now you do mutations outside of the state tree API, or outside an action, you could say. So this is one of the gotchas, but this is exactly why I was and still is a bit skeptic to like MobX. Like, the concept of observables and all that stuff is really, really nice, but it's not a single state tree, and I love the concept of a single state tree, and I think that's the way to go. So like in MobX, it's more about values. Like generally in JavaScript, you don't have that application structure around it. Things are happening there, but yeah. So and the point is that in MobX, when you change something anywhere, that can cause a new render. So I think you might be it's easy to fix things in a way that might be really bad later. With Cerebral, you have a very concise structure and a very concise concept on where to do changes. But yeah, there are always drawbacks to every solution. So how does this actually work with all this computed stuff? If you remember that a component registers to the container, and it tells it what state dependencies it has. So in this case, it tells that, okay, I have a dependency to app.title, but I also have this computed thing. And what actually happens there is that it extracts the dependencies of that computed function. So if you remember, here we have app.items and the index and app.currentHighlight. That has been extracted and also passed to the container. And if this highlighted item had a dependency to another computer, that would also be extracted when the component registers to the container. So this is how, like, the container becomes this puppet. It knows when components are mounted and unmounted, and it just updates this map of state paths against components. And it has complete control of React. So actually, when you add this Cerebral decorator, the component doesn't render at all. Like, should component update, returns false. But if there are new properties passed into the component, it will check those properties if they have changed and then allow the component to update itself. Or if this container specifically tells, okay, component, now you should actually re-render, it will also do that. And I think it's not common knowledge how much unnecessary work React actually does. And I think it's important to handle this. And I think this makes sense because when you do state changes, there are often not that many things that change, like for each state change. But then you have all the components. And previously in Cerebral and generally with immutability, you make every component check if on every state change, should I change, should I change, should I change? And that doesn't really make sense. So you have like many components, but you have few state changes. So with this structure, we ensure that whenever there's this little state change, it only has to iterate the state changes to figure out what components should update. Instead of each component kind of like are iterated and checks if they should update. Yeah, so I hope that made sense. Okay, so this is like the presentation, and then I have this little project here. Let's see if we can make sense of this. Okay, so this is hard-coded. I didn't make a really good demo here, but the point here is that when I click title changed, what I'm doing is that I'm changing the... Wait, let's look at the code first. Maybe that makes more sense. Okay, so I have a controller. So now you don't pass in the model anymore. It's like an integrated model. We might put that in its own project and make it a hard dependency. That's probably smart, but currently I think that this state tree is the way Cerebral should work. Anyways, we put in a title, some users, posts, and we have a comment there. And whenever I click title change button, it changes the title, and it also pushes in a post with a title, the user ID of the first, is it the first one? I think the first contact, or at least some contact in the contacts, and this comment ID I have up here. And this post uses this getter stuff to figure out actually what comments and participants should be used. Okay, so we just insert a post, and the post itself has the logic for building its structure for the UI. And then we have name changed, and then we change the name of the first contact and the second contact or user. So if we look at hello world, we are bringing in the title and we're bringing in the first user. So we're just combining the title with the first user. It doesn't make any sense, but that's how it works for demo purposes. And then we have items, which points to the posts, and it just passes in the index. Okay, and then we have the item also with a decorator using a dynamic definition of its dependencies, where it uses the index from the props to pick the post it's interested in. And it logs out the name and the first participant. Okay, so when I now render, we can see that it tells that the items rendered. It also rendered hello world, but I haven't logged that out, so yeah. When I click title changed, we update the title and we add a post. So what we can see here is that the state tree now said that, okay, the title changed and post 0 changed. And then we can see what state paths are in use in the application right now. So we have posts, post 0, title, and users 0. And these arrays are what components are actually interested in those specific state paths. And of course, it rendered items and it rendered the item. And when I now change the name, and this is really, really important. So I'm changing the name, but I'm changing them on the users directly, okay? But we have a user which is a participant of a post based on some comments. So you see how we are kind of like referencing things. And when I now change the name of the users, both of them changes. This one up here actually pointed directly to a user, like users.0 here. But this user was actually part of posts.0. But because posts.0 was referencing this user's other user, the state tree knew about that and could tell about that change, and then the component interested in post.0 would update itself based on the user inside the users array. And as we can see, when this change happened, it collected some components from users.0 because users.0 changed. It collected components from posts because we did a change within posts. And then we collected components specifically for post 0. And then we did one render on items and we did one render on item. So this is very, very predictable. And I really like this stuff. So yeah, that was my presentation. I hope it made sense and I hope you are as excited as me about this stuff. Okay, bye bye.